Hi, my name is Leslie Becker. I'm currently the head of the Design and Development Department at the VUT Technology Station. You will be hearing from my colleagues discussing more details concerning the design process. What I would like you to know is that here at the Technology Station, we assist companies, we assist people in industry to take their ideas to a final product. We will take ideas from the back of a serviette, as they normally say, on a piece of paper. We will design it, we will prove the concept. As you can see around us, we use different techniques to prove the concept. Once we finish with the concept, we will go as far as field trials. Once we're done with the field trial, we can further assist with production, tooling, and see the project through right to the end. Typically, an industrial design would entail looking at ergonomics, we look at aesthetics, we look at costing, we look at manufacturability, and we assist the client with all marketing-related materials, including two-dimensional renderings, three-dimensional prototypes, as you see again around me, using all different techniques, trying to equip the client to do the best with their product and hopefully assist them to get onto the marketplace.
Hello, my name is Tando Ndashe. I'm an industrial designer in the Design and Development department at VUT TTI. And we're basically a department of 5 industrial designers, 1 mechanical engineer, a team leader, which is our manager, Leslie, and 1 admin person. So this is basically our environment. It's an environment of creativity, environment where we apply a lot of different techniques. We apply software like SolidWorks, Sketchbook Pro, CorelDRAW, Rhino. We also apply conceptual development, prototyping in this area. We also have a workshop downstairs. We basically get messy. This is basically our studio where we do all the brain work and the computer work. So industrial design is typically a field where it has to do with mass production mostly. We work with products that would be mass produced. Industrial design is a field which would, in a hypothetical situation, help a person that has an idea or a concept to develop the idea or concept to a level where it can be mass produced or seen in industry. We would help people from a phase where they come with their idea and would consult with them, go through a phase of research, where in the phase of research we would then come up with the constraints that are needed for the design, market trends and all of the things that would relate to designing the product, present this to the client and sort of guide the client in terms of the design specification, what will be needed. And from research phase, then we would go into concepts where we present the client with 3 different concepts where they would choose from one of these concepts that we would then further develop into our refinement phase. In a refinement, we would look at things like your features, functional features and aesthetical appeal of the product. So there we go into the detail of the product and represent it to the client. And if the client is satisfied, we sign off on that phase and go into CAD design, where CAD design is where we basically do something like this, where we start taking the product into a 3-dimensional space. We draw the product, in terms of manufacturing requirements, in terms of aesthetics, stability, and all of that, taking all of those into consideration to produce a 3D model. And from a 3D model, we can then progress to a stage of prototyping. So from a 3D model, we can then produce prototypes such as these using 3D printing and different forms of production to show the client how the product would look like in 3-dimensional form. At this phase now, the client can engage with the product, look at it, feel it, test it, and also, have opinion on further refinement. Design process never stops. So refinement is one of the a continuous process within the design process, but it also has a phase. So after this phase, and after the client is sort of satisfied of what they want, then we would then go into production and also engineering drawings. But before we go into production, we go into a phase called testing. So then we will involve our mechanical engineer who then sit down and apply SABS standards to the product, make sure that everything is drawn to standards, is drawn to be applied to the required manufacturing process. For instance, if we choose injection molding, we need to conform to certain constraints within the manufacturing process, constraints such as tapers. We need to taper the product so that it can be removed from the mold. All those sorts of considerations would then be set down and evaluated by our mechanical engineer. So with our mechanical engineer, we would basically work with standards, SAPS standards, with quality control, you know, with a vernier, where he would sit down and measure our designs. Our mechanical engineer, great asset to the team, because now he is able to employ a different perspective to the industrial design team of mechanics, of electronics, where he would also look at strength testing. He'd also look at things that would affect the product in general in terms of the forces that would be acting on the product, and also advise on ways to combat such things. It also go into the design of the mechanisms and so forth. So this is our mechanical engineer, and yeah. And we also have a phase after this phase where we are sort of sure that our product will work and all of that, where we go into prototyping. And prototyping, we employ different processes as industrial designers for different reasons. I mean, prototyping is one of those phases where now the client gets to really see what their product looks like. So we can employ functional prototypes, where the purpose of the prototype is just to show the client how the product works. And there we can employ 3D printing, we can employ laser cutting, all sorts of different processes that are available to us here at VUT. But sometimes we need to outsource things. So in those situations, it will be typically things that we do not have here, like vacuum forming and injection molding. But even then, you know, we have an extensive range of facilities that allow us to produce quality prototypes for marketing purposes mostly, and also for demonstrational purposes, where we are able to, you know, sort of simulate the functions of a product, maybe an injection molded product or whatever, with the facilities that are available to us. So my teammates will go into further detail about all of these points, which is your research, your concepts, your CAD, your refinement, your prototyping, and your engineering processes that take place within the industrial design process.
Hi guys, I'm gonna be talking about research under industrial design. Before you start a project, it's actually the best way is to start with research. Research, it can involve checking if what processes are available, the materials and the materials that you can use, the properties, and you compare the materials, which material is going to be best suitable for a certain process. And you also get like parts that you can buy like from the market that you can include in your research if there are parts that are going to be able to work with your idea. As you can see here, I was actually looking at hinges. These are hinges that I'm actually thinking of using on one of the projects that I'm working on at the moment. And you also get like strap buckles, you get handles, and it's a whole lot of different stuff that you get from the market. The research, it helps with getting a better direction of what you want to accomplish in the design.
All right. A job of an industrial designer basically is to convert an idea from the idea phase into a product, into a physical product or a service. And in order for us to do that, we need to research about the product or about the background of the product itself. So what we normally do is we either look onto the internet for any inspirations or any design constraints that we need to look into. We need to look for market reliability or market choice of the product itself. How is it going to survive in the market and stuff? We also look at inspiration. That's part of the research itself. We have to look into other designers' works in order to find some sort of inspiration and find the direction where we want to go into for the product itself. And yeah, basically we just research a general outlook of the product itself so that we have our own direction that we need to move forward into. And from that point, we then go into conceptualization. That's where we put everything on paper. We also make physical models of the ideas that we come up with. And also to propose such ideas to the client itself, we need to communicate with the client and show them what we've come up with. And we also need to also find out what the client likes and what they doesn't like, and also derive a direction from that point thereof. All right, here we are basically putting our ideas down from our minds, from the research. We are going to use everything that we've collected and basically come up with the possible solutions that we need to propose to the client himself. This could be done using sketches. We can basically hand sketch our sketches. We can hand sketch our ideas onto paper, or we can just sketch them on the computer. There's a lot of mediums that you may use just to put the ideas onto something that a client can see and derive a solution from. So with sketches, we can also identify problems or identify solutions that we can come up with. Basically, we use doodle sketches. These are like ideation sketches that we draw on. These type of sketches are very messy. It's only understandable to the sketcher himself. What we do here, we focus on the main features that we want to put onto the design itself, or like say for example, how we want to fasten the parts together, or how the aesthetic's gonna be visually, and stuff like that, in very small details. And then we also move on to coming up with the proper overall type of sketches, where we just want to focus on one big idea of a sketch, of an idea, which could be dominated by one big sketch or a variety of different sketches on one page. This is just to communicate the overall idea that we need to propose to the client, and if he want to decide on the idea itself, or he wants to look at other different ideas. From there on, we could also use either one of the ideas, or we can combine the variations of ideas that we put into the table, and we create one concept that has been chosen from different other pages.
Today I'll be speaking about all the refinement processes and manufacturability of a product, and the stages we take to refine a product from start to finish after we selected the first concept, or the concept which the client has selected. Then we're refining it further to make sure that it's manufacturable. Check its market viability, functionality, economics. For example, we had this design. This was firstly done by one of our design team member. So if you can check the lid here, it's totally different from what I have here. So I had to go to CAD model. I had to use Solid Edge, which is the software we're using here. SolidWorks actually, which is the software we're using here for 3D modeling. Then I started modeling all the part. Then the first step actually, which I took, concept ideation of which direction I want to take, and during that process at the same time trying to refine some problems which I might encounter on the product, like the lid, how it open, where it's supposed to stop. I've included them on my sketches. Then even manufacturability, how the lid is going to clip on the body. Then my second product, which is already on production, is for one of our clients. You can see the first design here. It was big and not economically, I would say, fit to be used for where it's supposed to go. So the client was like, he asked us to refine it and come up with a more slimmer model. Then I end up coming up with this design. And yeah, you can see the color, the aesthetics of the product, like simple line work with some few details and the branding of the client's company. I think the product, it works well. I think so far the client is very, very happy with the product. He was so happy after we produced one of his 3D printed model, and he checked it, he tested it. Then after that, he started cutting his own mold. So if you can check, this is a final injection molded product, which is already on the market. So the client is already selling this product.
Good day. My name is Taba Mawinda. I'm a mechanical engineer at VUT Technology Station. What I'm doing here is basically when the designers are finished with their concept or their product, they bring it to me. I'm checking, for example, with this one here, I have to check the strength of this thing, and you see this one here, it's gonna use a spring. I have to check which spring is it applicable for this material, like the spring stiffness, and also the engineering drawings. But with the engineering drawings, like I have to consult with the SABS standards, and as you see this component here, what I was currently doing with this one here, I was doing reverse engineering. I was using this device here. It's called a microscriber. What I was doing here is I was checking the body accuracy of this component here, parts that I was doing just now.
Hi, my name is Ibrahim Mohammed. I'm part of the Val University of Technology Technology Station. I'm an industrial designer, and I've been working here for the last 2 years. Industrial design is a study of function, form, and how it connects between product, user, and the environment. As my colleagues have shown, there are different aspects that go into designing a product and different methods used to achieving a fully developed product. One of the aspects is producing a physical prototype, as shown here, which is tangible, which is physical, something that could be touched, felt, seen, and understood in the real world. Physical prototypes are used for different reasons, such as marketing, representation, testing, understanding physical dimensions, understanding proportions, and really putting it out into testing. That's one of the focuses that I will be showing, is how do you take a prototype, and when it's fully developed, how do you test? That's one of the things that me and my colleagues have done, is we've developed a small prototypes, and from the small prototypes it went into design considerations and tweaking and what if and what not and why and how, and all of the brains behind it. And one can only do that with a physical prototype. Is when you take one prototype, you start to physically see what happens in a prototype and how you can develop it and how you can change it. As shown here, and I will be showing you a 1:1 scale as well, is we've taken, this is a waterless toilet system, which was developed, designed and developed, and it went through a stage of all design stages and why we needed to do certain things to certain things. As can be seen, I'm standing next to the physical 1:1 scale of the waterless toilet, which we have shown earlier on, and which you'd see from the scale models. Once this development has been taken, it was now time for field trials, which would be testing out the whole system, how it works, if everything is functioning as we had predicted. Once this data has been collected, we could further develop the product to refine it to a point where it is fully refined and it is acceptable for the client.
Afternoon, my name is Mark Johnson. I'm involved in commercialization and intellectual property management at the VUT Science Park. I've been at the office for about 5 years now. In that time, we've grown the IP portfolio at the institution from 0 to 20. We've also tried to secure funding for various projects. We have 8 projects funded by Technology Innovation Agency, covering all aspects of manufacturing and also renewable energy. And we also have funded projects from the Industrial Development Corporation. I think the Advanced Manufacturing Precinct is a state-of-the-art precinct that creates great opportunities for the local industry. But besides trying to make money, we also try to impart and make a difference in our local community. We work very closely with the Sedibeng District Municipality, the local Mfuleni Municipality, and various CSI initiatives and local companies such as ArcelorMittal. We have an entrepreneurship program that is co-funded by SASL, which supports matriculants and assists them in business development and allows them either to start their own business on completion or to hopefully pursue further studies. We also have a walk-in community lab, which is less technically advanced than the manufacturing facility, but allows young people and adults to be exposed to additive manufacturing and to develop ideas and products. To date, we have trained almost 100 people in that laboratory since the beginning of 2015, and we continue to train. We also have various food feeding schemes and agricultural projects that we have underway, and we hope that that creates the social difference that is so much needed in our community, which is extremely impoverished. So I think we are very privileged to be in this space, because not only do we make a financial contribution, but we really do change lives at VUT.